Hey everyone, welcome to this Educated video where we're introducing what we call the fundamental theorem of algebra. So this is the very first standard in Unit 6. So we've already made it through 2 units together, which is really exciting. And now we're going on to Unit 6, and the very first unit says that we need to cover the fundamental theorem of algebra. Let me just go ahead and underline that. The fundamental theorem of algebra. Okay, so let me just go ahead and write out what the fundamental theorem of algebra is. The fundamental theorem of algebra applies to any polynomial. So we've already defined polynomials, and we've worked with polynomials quite a bit. So let's just take a function p that is a polynomial. I haven't told you what degree it is. We just want to write this out in general. So p here is just any polynomial. This could be a quadratic. This could be a polynomial with a degree of 3, or a degree of 4, or a degree of 5. But right now, all you need to know is that this is just some polynomial. And if I want to write the fundamental theorem of algebra for any polynomial, I would say that it is a, where a is just some constant, x to the n power plus b x to the n minus 1 power. So if this were a quadratic, this would be something like 2, so x to the 2, and then the next term would be some number b times x to the 2 minus 1, so just x to the 1, and we just continue this process in general, plus dot dot dot, because I'm not saying that this has to be a quadratic. I'm writing this in general. N could be any number really. N could be 7 or 8 or 9 or 10, and we just continue this process all the way down to plus some constant k. So anytime you hear the fundamental theorem of algebra, what we're referring to is an expression that just looks like this, but this isn't really the theorem itself. This is just any polynomial written out in general form. But what the fundamental theorem of algebra says is that this expression, any polynomial in general will have n roots. Okay, n roots. So here's my n, which is going to be the highest degree or the highest exponent that I have in whatever polynomial this is. And we look at it, and the fundamental theorem of algebra says that this polynomial, whatever it is, will have n roots. So what does it mean that there are n roots? That's kind of vague, but what it means is that there are n numbers. So n numbers that I could plug into this equation to get 0. So there are n numbers that I could plug into this equation, and if I plug them in for x, then the polynomial would equal 0. That's what I mean by n roots. Now, if you don't quite understand exactly what this is saying, don't worry, we're going to work with it for different types of polynomials, and hopefully it'll all come together in just a few moments. But the most important thing is, you guys know that my number one goal is to prepare you guys for college. And I want you guys to be able to work with expressions like this, and to talk to people about expressions like this. Because even though it seems complex, when you get to college and you're talking to smart people, I don't want you to sound like this. Or even worse, like this. So make it your goal today to fully understand exactly what this fundamental theorem of algebra is saying, so you don't sound like that guy. So let's see. Let's look at this on a graph first, because graphs put a nice visual representation to what we're saying. So the fundamental theorem of algebra, in general, is this expression that I am circling here. This p of x is equal to all of these terms on the right-hand side. And it says that we're going to have n roots. So let's look at that on a graph. Let's say that we have a quadratic that is a degree of 2. Now I'm not going to put numbers here. I just want to draw this in general. So if I have a quadratic, you know it's going to make the shape of a parabola. So I can just draw down through here. Now that's just a parabola, and we'll say that's a degree of 2. So that's a degree of 2. And I could ask you, how many roots are there? For this equation, or for this graph, that appears to be quadratic? Yeah, so hopefully you were able to say that we know the roots are going to be the points where our graph crosses the x-axis. This is something that you guys have probably studied before, but this is telling us the zeros of the function. That's also a term that you may have heard before when you were studying quadratics with Miss Tracy. But we look and we say, okay, so we know that there are exactly two roots to this equation. There are two roots, and these solutions to this graph lie here where the parabola crosses the x-axis. So these 2 points are the roots. Now, just let me clarify exactly what I mean by roots, because you'll hear roots called different things. So roots, and maybe I'll make some notes down here, roots are also called the solutions. So solutions, that's the same thing as solutions. You'll also hear these things called the x-intercepts or zeros or x-intercepts. So all those terms mean the same thing. So if we're dealing with an equation that's a quadratic and it has a degree of 2, it's telling us that there are exactly two solutions that would make the polynomial 0. So there are two real numbers in this case, that I could plug in to make the polynomial 0. Now let's look at something a little bit higher than a degree of 2. Let's look at something on the second graph, maybe like a degree of 3. So that would mean that we have a polynomial where our n is 3. So we would expect there to be 3 roots or 3 solutions. Okay, if we're looking at a degree of 3 solutions that would give me 0 in that particular polynomial. So maybe you can go to Desmos if you'd like to and plot just some random cubic functions, so y equals x cubed or y equals x cubed plus 2x, anything like that that has a degree of 3. And what you should see is something that looks like this. And before I do, I'm just going to go ahead and draw. Let's go and label these just to make sure you see y, x, y, and x. So here we go. We're going to plot, we're just going to sketch a really quick, like, degree of 3. So maybe it'd go something like this, and it'd cross there, bam, bam, and bam. Just like that. So here you can see that this function crosses the x-axis at 3 locations. So we would say that each point here, each point there would be a root. Each point there is a root, and this is for a degree of 3. So we have, I'll put here a note, degree equals 3. And so there are three numbers that we could plug in to whatever function it is, whatever polynomial, and it would give me 0 out. So we'd say that there are 3 roots, 3 zeros, or 3 solutions to that problem. And in this case, they are real. They actually lie on the x-axis, so we have 3 real roots. And likewise, if we were to look at something, say like a 4th degree polynomial, we would have something that looks like this. We would have the function go up, and then down, and then back up, and then back down. And here, in this case, you can see, and I'll do this in a different color, you can see 1, 2, 3, and 4 points where it crosses the x-axis. And each of these are going to be the roots, the solutions to whatever function that's a degree of 4 here. And I'll put a note that that's d equals 4. There are 4 exact roots here. Now this is the point where I'm going to tell you that in the past, your math teachers have probably lied to you. But at the time, it was just best to lie to you, so that way when you get to my class, I can just tell you the truth, just to help you learn. So in the past, you may have had functions that looked like this. Let's go back to the degree equals 2, and you know that you've had functions in the past that look something like this. Maybe way up here, they don't even cross the x-axis. And in the past, you've probably been told that quadratics that are polynomials that have a degree of 2, they can either have 0 solutions, they can have 1 solution, or they can have 2 solutions. At max, they can only have 2 solutions. They can't have 3, they can't have 4, they can't have 5. They can either have 0, 1, or 2. But we're correcting that. So even though your math teachers may have lied to you in the past and told you that you'll either have 0, 1, or 2 solutions, according to the fundamental theorem of algebra, okay, if you have a polynomial, be it quadratic, be it cubic, be it quartic, you are always going to have n roots. But if your function, like this, does not cross the x-axis, you may be asking yourself, well, what are the roots? Well, luckily we've been able to study, and we studied together, complex numbers. So anytime that you have a function like this that does not cross the x-axis, that means your roots are going to be complex. So if your function does not cross the x-axis like our red one did, see here we had 2 real solutions. If it does not, there are still 2 roots. The fundamental theorem of algebra still holds here. However, in this case, our 2 solutions are going to be complex, but it's very easy because the 2 roots to this equation, if you find one root, you automatically know that the other root is going to be the complex conjugate of the other one. Okay, so if you find one root, take the conjugate, and then you found the other root. There are still 2 here, but they're going to be complex. Or really, I should be saying they're going to be non-real numbers in this case. And the same is true for, say, let's do this one in green too. For something greater than 2, let's say that we have an x cubed, where it goes up like this. It does cross the x-axis, but then goes back down, but doesn't quite make it, and then goes back up again. Now in this case, this is also going to be, I'll just put a little note here, this is still degree of 3. I don't know what I'm trying to draw there. Degree of 3. Now you tell me. So we just drew this, this function that has a degree of 3. Tell me how many solutions or how many roots are there to this function if the fundamental theorem of algebra is true. So go ahead. What do you think? How many solutions or how many roots are there to this function? Yeah, so hopefully you were able to say that there are 3. So we've got a degree of 3 here. Degree is equal to 3. That means there are going to be 3 roots. 3 roots here. Now, let me ask you, how many of these roots are real and how many are complex? Yeah, so hopefully you were able to say that because you can see here, you can see that, I'll do this in, I guess probably yellow. So here, it crosses the x-axis 1 time, so we know there's at least 1 real solution. Now this function, if I follow it, it doesn't cross the x-axis again, and I know there are 2 more roots that I have to have because the fundamental theorem of algebra says that I have to have 3 roots, which means that if there's one that is real, that is one that crosses the x-axis, that means there have to be 2 more that are complex. And that would make sense, right? So if there's one, there has to be 2 more because I said earlier, every time that you find a solution that is complex or a root that is complex, its conjugate will also be a root for that function. Because complex roots, if you look at the bottom, complex roots come in pairs. Complex roots come in pairs. Therefore, that said, you cannot have an odd number of complex roots. So that's it for the introduction to the fundamental theorem of algebra. Go ahead and keep your notes, and as soon as everybody finishes, we're going to pick back up with some guided notes. So if you didn't quite understand this, just raise your hand, and I'll come over and I'll work with each individual person or each individual group to the best that I can.